All right, back at it with these pathways problems. Wanted to do number 1.26 from your textbook right now. It's a pretty simple problem, but it demonstrates a few things that are key to these unit conversions, okay? If you're not familiar with that, this is going to be helpful for you. It says the average radius of a lysozyme enzyme molecule, it's an enzyme present in tears, is about 1430 pm. PM stands for picometers. Of course, this lowercase p is pico. It's one of those metric prefixes that you'll need to know. We want to know what is the radius in nanometer units. So we're going from picometers to nanometers, essentially. That's going to be our task here. So if you want to, I'm always a big advocate for writing out what the conversion involves on your piece of paper. Keep your thoughts organized. Now, what information do we need to solve this? Well, we go about doing it our standard way. We write the information that we know that we want to convert away from with associated units, and we multiply by our conversion factor. So I write 1430 picometers multiplied by the conversion factor. The next thing I always do is think about what needs to go in the top and the bottom of this fraction. What needs to go in the numerator and the denominator, as it's called, okay? Remember, the undesirable units, that's where I always start. Undesirable units, what we're converting away from, goes in the bottom so that the units cancel when we do the math. The desirable units, here that's lowercase n and then an m, nanometers, goes up in the top. And the only thing that we're left with now is finding numbers to put in this fraction. Okay, so that's what we've got to do, and then we can do the math and solve things. Okay, so how are we going to do that? Well, to know what numbers to put in the numerator and denominator, we need to remember these metric prefixes. Okay, these are listed in your book. It's on page 14. Really important, if you're not familiar with these, that you familiarize yourself with them and memorize them. It's a pretty common thing to have to do here at the onset of this class to convert between different metric prefixes. It's a type of question you'll see at the end of the chapter. Of course, this is an example of that. It could be on your homework or possibly on your exam. Okay, so you don't want to lose points because you're not familiar with these. They're used a lot in the sciences, so it's really time for you, as you work towards being a professional scientist, that you actually memorize these and learn how to use them, okay? I wrote several of them up on the board here. Okay, we're starting with ones that are very big, and the way these usually work is there's some kind of base unit here at 10 to the power 1, essentially, right? And above that, there are so-called the big units. I like to call them the big units, and then the small units, and really small down here at the bottom. And these are really big up here at the top, okay? But the ones above 10 to the power 1 is giga, mega, and kilo. Giga is 10 to the 9th of a quantity. That's a billion of the quantity being measured. Mega is a million of the quantity being measured. Kilo is 1,000. So if we say kilometer, everybody's familiar with hearing about kilometers, km, right? That's 10 to the 3rd, which is equal to 1,000 meters in the case of a kilometer, right? 10 to the 6th is equal to a million of something. So just like I say kilometer, I could say a megameter, right? And that's a million meters, right? And 10 to the 9th, of course, is a billion. There'd be 3 more zeros. I don't think I have space to write that, so I'm going to not do that. Now, the unit below 10 to the power 1, centi, milli, micro, nano, and pico, all are the smaller units, right? Now, if we say a centimeter, cm, that is 1/100th of a meter. That's equal to 0.01 of a meter, or 1/100th of a meter. Milli, likewise, I might talk about a millimeter. Well, that's 0.001, or 1,000th of a meter. There's micrometers, which is a millionth of a meter. There's nanometers, even smaller than that when we talk about light and wavelengths of light. It's measured in nanometers. This is a billionth of a meter, or 10 to the minus 9. And then finally there's pico. Pico is very small. It's 10 to the minus 12. Okay? So all these metric prefixes are really important in the class. Understanding what their magnitude is will help you understand a lot more about the scales of what it is we're talking about. So definitely devote this to memory. You're going to need it for your homework, and you're going to need it for the exam, okay? That's one thing that you just have to memorize here at Chapter 1, I think, and become familiar. Now, back to the problem. We've got this molecule. Lysozyme is an enzyme, which is actually a protein. Proteins are pretty big molecules, as it turns out, on a molecular scale, but if we look at the measurement for the radius of this molecule, it's about 1430 picometers, which is one of our smallest base units. Okay, and that makes a lot of sense because even though this is a kind of big on a molecular scale, a protein, molecules are still really, really, really small. They're really tiny, way too small to see with the naked eye or even an optical microscope. Okay, so this is kind of consistent with our mental model of what molecules might look like. They're pretty small. So let's do this unit conversion. Now again, back to the problem. We take what we've got in the undesirable units, convert to the desirable units. We need a conversion factor, the mathematical conversion factor, to help us do this. So where do we see pico and nano on our chart? They're down here at the bottom of the small. We said earlier that nano was a billionth of something, and pico is 10 to the minus 12th, or a trillionth of something. What is the mathematical factor between these two? 10 to the minus 9 and 10 to the minus 12 here. It looks like the mathematical factor is 10 to the 3, or 1,000. And in many cases, if you see the ones that I listed up here, you will see this factor of 1,000 difference, or 10 to the 3. The exception is centi. It is kind of a common unit, and we hear about that one. That's only 10 to the power 1 different between milli, okay, or a factor of 10 different. But oftentimes, these metric prefixes are arranged such that they have a factor of 10 to the 3 or 1,000 difference. Pico is 1,000 times smaller than nano. And nano is 1,000 times smaller than micro. And micro is 1,000 times smaller than milli. And so on up the list, okay? So what's the significance of that then for our conversion factor? Well, if there's a factor of 10 to the 3 difference, and pico is 1,000 times smaller, it takes 1,000 picometers to equate or be equivalent to, physically, 1 nanometer. And that's kind of the key bit of information that you need to see here. Because this is this factor of 10 to the 3 difference, a pico is 1,000 times smaller than a nano. And because of that, to make this conversion factor physically equivalent, 1 nanometer is equal to 1,000 picometers. We do the math and we're done. So we divide by 1,000 and it looks like 1.430 nanometers should be reported as the radius of this lysozyme molecule, okay?